In today's class, we are going to begin with the language of chemistry. Okay, so first we are going to begin by defining what a symbol is. So symbol has two definitions. One is qualitative, which denotes the quality or the type of elements that is, and the second is the quantitative definition. In the quantitative definition, we understand that what is the weight or determine the weight of that particular atom or the symbol, whatever we use. Okay. So first is the qualitative definition. So a symbol represents a specific element or one atom of an element. Okay, here I'll discuss some examples of sulfur. We'll understand what the different symbols determine. So S, if I say only S, then this represents one atom of element sulfur. If I write 8S, so this represents 8 atoms of element sulfur. If I write S8, S8 represents one molecule. A molecule of sulfur has 8 atoms, 8 sulfur bond together to form S8. So S8 represents one molecule of element sulfur. And if I say 2S8, then this will represent 2 molecules of element sulfur. So these are different denotions where we need to understand what denotes what. And second is the quantitative definition. So by the term itself, we understand that this measures the quantity or the value, that is the weight of the element. So a symbol also represents the weight of the element equal to its atomic weight. So suppose I say Na1123. So this denotes the atomic number which is given as a subscript. The writing at the bottom is called subscript and the writing at the top is called superscript, and this superscript denotes the mass number, or what we also call as the atomic weight. Mass number and atomic weight are not exactly same. We have already discussed what is the difference between mass number and atomic weight. Just to recap, atomic weight, we also take into account the mass, that is of electron, but in mass number we completely neglect our electrons. We only consider protons and neutrons. Okay, so after quantitative definition, we'll see some symbols for some metals derived from their Latin names. So this potassium, helium and sodium, natrium is very common, but we have more elements of which we use the Latin names very commonly. One is copper, whose Latin name is cuprum, hence its symbol becomes Cu. Then we have iron, Latin name ferrum, hence the symbol Fe. Potassium, as we all know, the Latin name is kalium, denoted by K. And gold is aurum, denoted by Au. We have silver, Latin name argentum, denoted by Ag. Lead, plumbum, denoted by Pb. Sodium is natrium, denoted by Na. And the last, mercury, its Latin name is hydrargyrum, denoted by Hg. So these are some symbols of metals which are derived from their Latin names. The next topic we dive into is valency. So what is valency? The topic valency is also discussed before. In the previous part when we discussed valency, we saw that the number of electrons it gained or it lost in order to attain the electronic configuration of the nearest noble gas. So the number of electrons it gained or lost, we use that as valency. A more appropriate definition of valency is the number of hydrogen atoms which can combine with or displace one atom of the element or radical so as to form a compound. For example, if we say oxygen, so oxygen on reaction with hydrogen forms water. So how many hydrogen did oxygen take? Oxygen took 2 hydrogens, so hence the valency of oxygen is 2. For doing this, we need to know the formula of particular compounds. So instead of this, it's better that for oxygen, its electronic configuration is 2,6. Nearest noble gas we know is for oxygen is neon. So oxygen gains 2 electrons to form the electronic configuration of neon, that is 2,8. Now this has 10 electrons. So see, number of electrons over here was 8. Number of electrons here is 10. The number of protons here was 8. the number of protons here is also 8. The number of protons do not change. So what is more? The number of electrons is more. By what number? By 2. So 2 and the charge of electron is negative, hence negative. So therefore valency of oxygen is minus 2 or 2 minus. So this is a more authentic and a very easier way as compared to this to learn the valency of different elements. Okay. Next, let's take a metal. So let's say potassium. Potassium is 2881. So this loses one electron to form K. So this becomes 288. Nearest noble gas was argon. Electrons 10. 19. Protons 19. Electrons, one was lost, so becomes 18. Protons 19. So what is more? Proton is more by what number? 1. And protons is more, so positive sign. So we have K plus or K plus 1. So therefore valency of potassium is plus 1. It's better to use this method in order to find the valency of different elements. So from this we conclude certain things. We note that the valency of all metals and hydrogen is considered positive because they lose electron. The second one is that the valency of all non-metals or groups of non-metals is taken as negative. Okay. The next topic is variable valency. So what is variable valency? So valency is basically the number of hydrogen atoms that can combine or displace with, or in a simple language what happens is the nearest noble gas configuration that an element obtains. In order to gain that noble gas configuration, it loses or gains certain number of electrons. That number of electrons we say is the valency. For variable valency, what happens is certain transition elements, the elements that are present in between the metals and the non-metals, that portion from group 3 to group 12, the transition elements, they are quite radical. What I mean to say is that they are not very stable. So what happens is sometimes they lose one electron to become stable. They change their electronic configuration in such a way that they can lose sometimes one or sometimes more than one. So they not only lose electrons from their valence shell, that is the last shell, sometimes they even lose electrons from their last second, that is the penultimate shell. So in such a case, what happens is we see that it exhibits more than one valency, hence we call it as variable valency. So variable valency is basically certain metals, the transition elements that is present in the group 3 to group 12, from there certain metals exhibit more than one valency hence showing variable valency. So why does this variable valency occur is that because they sometimes lose only from their last shell, that is the valence shell, and sometimes they even lose from their penultimate shell, the last second shell. So that is why it exhibits more than one valency, hence variable valency. So an atom of an element can sometimes lose more electrons than are present in its valence shell. That is they can lose from its penultimate shell, that is loss from penultimate. Penultimate is basically the last second or last but one, that is the last second shell, and hence exhibit more than one or variable valency. Okay, so variable valency, so plus 1, plus 2, plus 3, plus 4. Plus 1 is shown by copper, and copper also shows plus 2. Mercury shows plus 1 and plus 2. Silver also shows plus 1 and plus 2. Gold shows plus 1 and plus 3. Iron shows plus 2 and plus 3. Lead shows plus 2 and plus 4. Same for tin. Same for manganese as well. Okay, I am writing in this space. Manganese as well, plus 2 and plus 4. And platinum also shows plus 2 and plus 4. Make sure that you write this at the end. Because of lack of space, I wrote it in the middle, but write this at the end. It will help you look at the table more easily. This becomes our chart for variable valency. Next is a radical. A radical is basically when a group of atoms, they come together and they behave as a single unit and also show certain valency, then we call that as a radical. So a radical is a group of atoms of elements that behaves like a single unit and shows a valency. And now this valency can be positive or negative. So hence we also call it as positive radical and negative radical. So example of one positive radical is ammonium. Ammonium, the formula is NH4 plus, and a negative radical is hydroxide, whose formula is OH1 minus. We can write 1 plus or just plus, that is also fine. Now, this table that you have in your book in page number 3, this you need to memorize, because afterwards we'll be learning how to write chemical formula, and in writing chemical formula this is essential. Okay, next topic is a chemical formula. So what is a chemical formula basically? A molecule of a substance that is element or compound that can be represented by symbols. Now this representation by symbols is known as chemical formula. Okay, so we know what an element is. We do not know what a compound is. So next we are going to learn about compounds. And before that, let's look at some example of element. If I say sodium in itself is a chemical formula, because this is a monoatomic element. That means in this molecule there is only one atom. This is a monoatomic element. Next, let's take example of oxygen. Oxygen, when I say oxygen molecule, so this is O2. This is a diatomic element. Means its molecule has two elements, two atoms. Then say ozone, O3, is a triatomic element. So like that we have different elements that have different number of atoms. So this is how an element forms a molecule. And compound, we have different molecules, that different atoms that combine together to form a molecule of a compound. So this is molecule of water. So water is a compound and water molecule is H2O. So water is basically a compound. Just like water, there is another compound, say NH3. This is a molecule of ammonia. Ammonia now here is a compound. Okay, so let's see what a compound is. Compound. So a compound is a pure substance composed of two or more elements combined chemically in a fixed proportion. Like example is water. So in water, what happens is there is a one oxygen molecule that has 6 electrons in its outermost shell. This is not there, and it reacts with 2 hydrogen atoms in order to gain stable electronic configuration. Hydrogen needs one more to become stable, so it reacts with 1, and oxygen needs 2 more, so 1 is attained by this hydrogen and 1 from this hydrogen. So this, they come together and this comes together. So what we get as a result is oxygen, 2 electrons over here with hydrogen, 2 electrons over here, 1 of hydrogen, 1 of oxygen, and this oxygen had 4 electrons of its own. So this is how reaction takes place, and this is a fixed composition. Wherever you go, whenever you take water, oxygen, there will be one atom of oxygen and 2 atoms of hydrogen. This composition remains fixed. So let's see some characteristics of compound. What characteristics does a compound exhibit? So number 1 is compounds have components present in a definite proportion. That is, like for water, 2:1, 2 atoms of hydrogen, 1 atom of oxygen. So this is a definite proportion. Number 2, compound is always homogeneous. So throughout the solution, wherever you take any sample, so what happens is that sample will always be homogeneous. The constitution will always be the same throughout the whole solution. So a compound is always homogeneous. Third characteristic is that particles in a compound are of one kind. Okay. Now what does this mean is that water will always have hydrogen and oxygen. The particles of hydrogen, particles of water will remain same. We will not see that there is nitrogen in water. Like in the formula for water, we cannot have nitrogen. So the particles that are there in a compound are always the same. They are always of one kind. Number 4, compound has a definite set of properties. Like if we consider water, water is a good fire extinguisher, and water can also be used by animals and plants for different processes. So water has its own set of properties. Now water is liquid at room temperature. So that is a property. Its melting point is say 0 degree centigrade and its boiling point is say 100 degree centigrade. So these are properties and these are definite for water. For a compound they do not change. For different compounds there are different values, but for one particular compound, say water, it is the same all throughout. And the fifth property is that components in a compound do not retain their original properties and can be separated only by chemical means. So like water again, let's take example of water. How is water formed? By the combination of hydrogen and oxygen. Hydrogen is highly combustible. Oxygen is a supporter of combustion. So oxygen is needed for combustion to take place. So both of them help in combustion or are highly combustible, but water acts as a fire extinguisher. So it's just the opposite. And hydrogen and oxygen both are present as gases at room temperature, whereas water is liquid at room temperature. So hence the components in a compound do not retain their original properties. And now to separate hydrogen and oxygen, so we need some chemical means that we cannot just heat them, or we cannot say by heating or by any physical means we cannot separate them. We will need chemical means in order to separate the components. Like suppose if we take water and salt and if we mix them together, so that is not a compound, it's a solution. It's a solution of water and salt. If we heat it, what happens is water evaporates and salt is left. So we can separate them by physical means. But this here is a chemical compound. They have combined chemically. So when there is a chemical compound, we cannot separate by only physical means. We need some chemical means in order to separate them. Okay. So next you need to learn this different important compound. Chloric acid, its formula is HCl. Acetic acid, its formula is CH3COOH. So these are different salt names, hydrocarbons, alcohols. All this you need to learn, because when you will be writing word equations, that will come a little later in the chapter. So when you will be writing word equations, what will happen is that if you do not know the formula for a compound, you will not be able to proceed. So this will be very important later on. So please remember and learn this one. Okay. So the last topic for today is writing the formula of chemical compounds. Okay. So I'll show some examples on how to write them. They are not difficult, but what is important is that the first page that I showed you from the book, the list of radicals, you need to learn them by heart. For example, let's say I need to write the formula for magnesium nitride. So here I need to remember that magnesium is Mg 2 plus and nitride is N 3 minus. So what happens is magnesium, the valency for magnesium is 2, valency for nitrogen is 3. So is there anything that we can cancel? There is nothing we can cancel. So 2 goes to nitrogen, 3 goes to magnesium. The crisscross takes place. So chemical formula for magnesium nitride Mg, there is 2 and 3 goes to Mg, so Mg3, nitrogen N2, so Mg3 N2. Second example, say of a zinc carbonate. So zinc is Zn 2 plus, valency 2, carbonate CO3 2 minus, its valency is also 2. Now what happens is 2 ones are 2, 2 ones are 2. We can cancel them. So 1 goes to this one goes to this. So therefore, chemical formula for magnesium nitride, for zinc carbonate is Zn1 CO3 also 1, so Zn CO3. The third, say iron 3 nitrate. So iron 3 is basically 3 means its valency we are taking as 3 plus, and nitrate is NO3 minus, so valency becomes 1. We cannot cancel anything. 3 goes to nitrate and 1 goes to iron. So chemical formula for iron 3 nitrate is Fe, 1 comes, and NO3 we have 3. So NO3 is a radical, we place a bracket and then we write the number of radicals that are there. So there are 3 NO3 radicals, so that's why we write NO3, and outside bracket we have 3. Okay. Next example and last for today is aluminium sulfate. So aluminium valency 3 plus, so 3. Sulfate is SO4 2 minus, valency 2. We cannot cancel, so 3 goes here, 2 comes here. So we have therefore chemical formula for aluminium sulfate is Al2 SO4, this radical, there are 3 of them, so SO4 in bracket and 3 outside. So this is how we form chemical formulas, and this formation of chemical formulas is completely based upon how well you have learned the radicals. So make sure you learn radicals properly, and also all the important chemical formulas of compounds that are there. So this too you need to learn for proceeding further in the chapter. Okay, with this we end today's class. Thank you.